Hi everyone, Kevin Oversappian here from Filmstorm Studios, and today we're going to have a look at how to create an IK system from scratch. It's probably going to be a bit of a long tutorial, but that's just because I need to kind of explain all of the different methods and variables we're going to need to create. And from the start, we're going to be creating it using our movement input script, which we have created in a lot of other tutorials, and we have used in a lot of different tutorials. But basically, what our script's going to let us do, so when we have these kind of situations, our feet will automatically be adjusted to the different levels. And also when we have like these kind of ramps, our feet will adjust dynamically and he won't kind of be floating. So we're going to have a look at how to create that, and we're going to jump into our movement input script. And I just wanted to point out that in our folder, or the folder that you'll get to download, we're going to have a start folder, which is going to have the starting script, which is basically just like this. And then we're going to have an end folder, which is going to have the end script. So if you get stuck and something doesn't work out, you can go back and have a look at the end script and then kind of figure out what you might have typed in wrong or did wrong, and it's going to help you fix that up. And it saves us giving more support to really try and answer your comments and stuff. So that's one handy little thing that we're going to do. So look out for that. But to get started, what we're going to do is we're going to start to create our variables. And all of these variables are above our first method and inside our actual class. So what we want to start off with is probably create a header. And we can call this guy feet grounder. And this is going to basically handle all of our feet grounding. And I like to create all of the variables I'm not going to be using, or like not displaying inside this header, because if we say we go back to our Unity and we jump into the character once it finishes compiling, you can see we have a new header called feet grounder. So this is where we're going to put all of our logic, so we can have little drags and click buttons and stuff. It's not as powerful as a custom inspector, but it's going to do the job. So for now, let's just go through and create our vectors and quaternions, because that's what we're going to need to store our feet IK positions and like rotations. So let's quickly jump through that, and we're going to put this above our header. So this is just going to be where we store all of the stuff that we're not going to see. So private vector3. So this is going to just be a vector. It's pretty straightforward. And this is going to be our right foot position. You can put a comma, and that's going to create another vector3 and straight off the bat, so you don't have to type it again. And that's going to be our left foot position. We also want a left foot IK position. And we also want a right foot IK position. And all of these will be vectors that are created. So that's nice and handy. Nope, I don't need an update, thank you. Okay, and now let's create a private quaternion. Quaternion, can never spell that right. And this is going to hold our rotation. So this is going to be our left foot IK rotation and our right foot IK rotation, if you guessed that one. Cool, and now we just need two floats. So private float, it is going to be our last pelvis position on the Y and comma, and we want to create another one. Let's just call it, we actually need three more. One for the right foot and one for the left foot. So last right foot position and last left foot position Y. There we go. So that's our all of our feet and our pelvis. So now we want to come down into here and let's start creating the fields that we'll be able to see. Okay, so we need a public bool, and let's just call this enable feed IK, and make that lowercase k, and let's just make it true because we want it to be working from the start. I want to show you using private. So let's say we have a private float and this height, and we're going to call it height from ground raycast. So basically how high it is from the ground, and we want the player to be able to, or we want you to be able to adjust it. So if we come back to here, you'll notice we can only see the feed IK. We can't see this float that we created. So we actually need to use this function called serialize field, and it's going to allow us to see our private fields, but it's going to serialize it. There you go. So now you can see that. And then if you want to also do this, you can create a range, and you can create a range between like 0 and 2, and close that one out. And if we jump back to here, you'll now see that this will switch from a box to a range. So then you can actually drag this backwards and forwards. I kind of prefer having the sliders, and so you can kind of visualize the max and how far you should actually be pushing it. And then you can specify how high or low you want the range to be. Okay, so now, as you can probably guess, we want to create another range. We can also probably make this between 0 and 2 again. We want to serialize this and create a private float, and this is just going to be the call it raycast down distance, I assume, and make this 1.5. Good. Let's make another. We're just going to serialize this one, and this is going to be a private layer mask, and this is going to be what our environment layer is on. So what is our environment layer? We will be able to select that, and then we want to serialize a private float for our pelvis offset, and this can be just 0 because we want to be able to change that later. We can create a range between 0 and 1, and this one will be a serialized field private float, and this private float will be the pelvis up and down speed, and our pelvis up and down speed right now is 0.228. I find that's a good number, but you'll be able to adjust that later, just so it initializes with some good values that will work nicely for you. And we want another private float, and this is going to be our feet to IK position speed, and this is going to be at a constant rate of 0.5. Perfect. Now we just need 2 public strings for our pro features. I want to explain this later, but we're going to call this left foot anim variable name is equal to left foot curve, and public string is going to be equal to foot right anim variable name, which is our right foot curve. Good. Good. Now we just want a public bool, and this one will be allowing us to enable our pro IK features. So if our users don't want to use this custom feature, we'll be able to turn it off so it's not running. And we also want a public bool to show our solver debug. Okay, so that is all of our variables. If we save this, jump back into here, we can quickly set up our environment layer. Okay, so if we set up, so our environment layer is currently on default. So that means we want to come to Atom and make this default. So that's going to be our correct environment layer. And pretty much everything else we don't need. We'll talk about the Pro IK feature later, which will be a bit more of a hassle to set up, but I think I've already got the curve set up, but we'll check that later. Okay, so let's jump back here. And I wanted to quickly show you these things called regions. And regions are really cool because if you type in hashtag region and then type a name, we can then encapsulate all of our code into these regions. So you can come down and put end region, and as you can guess, it's going to collapse between here and here. And if you come over to the left side, it's going to highlight this region, and you can collapse it. And that's going to hold everything inside that player movement area. And that's going to be really nice later on when it gets really messy. You can kind of break everything down. And you can even do the same in here. We can come into here and go region and call it variables. And then at the bottom, where there's no more, we can go end region. And we can collapse this. And that's all of our variables. And this we can call another region and call this initialization. That's not spelled right. Well, let's just copy this one. There we go. Initialization and end region. Boom. Initialization, variables, player movement. And now we can create, and then as soon as you start to make another region, it's going to expand again. So this region will be feet grounding and end region. Okay, now we can collapse this one. And this region, it's going to expand that one again. And this region is going to be feet grounding methods, which is going to hold all of our calculation methods for the feet IK. Okay, so we're going to be using fixed updates and on animator IK methods. So in order to do this, let's create a fixed update. And we also want to create another private on animator IK. Very nice. Okay, and for our feet grounding methods, let's create our different methods. And for this method, if you can hear paper rustling around, it's just because I have notes, because there's a lot of information I need to remember to set this up correctly. We need to create a void, and this is going to be move feet to IK point. And we need to use an avatar IK goal, and we're going to call it foot. We're going to use a vector 3, and we're going to call this our position IK. We can call it holder. Quaternion. We can call this rotation IK holder. And we want to create a reference float to that last foot position Y. Okay, so that's all in there. So that one's going to be that one. Let's just create the actual method. Okay, so that's that one. We want to create another private void. And this void will be our moving the pelvis height. And for the next one, we're going to also create a private void. And this is going to be our feet position solver. And our feet position solver is going to need a vector 3, not a 33, a 3. And we want to reference our sky position from where our raycast will be shooting from. We want a vector 3 feet IK position. And also we want to reference our quaternion for our feet IK rotation. And let's close that one out. Okay, and finally, I think we just need a couple. Oh, do we need any more? Oh, we need one more. Private void, and then we're going to call this adjust feet target. And this one will be referencing a vector 3, our feet positions we need a human body bone for the foot. Cool. Okay, so to start with, let's fill out our fixed update, because then we'll be able to fill out and call all of this stuff that we need, and then we can come and fill out each individual method. Okay, so in our fixed update, if we want to start, if our enable feet IK is equal to false, then, well, we don't want it to run, so then we want to return, and that's that. So technically that is the system when it's disabled. That's all that's going to happen. It's not going to run. Also, we need to check if we have our animator. So if our anim is equal to null, if our anim is equal to null, then we want to also return, because we need an animator for our system to function. And this is just to stop it from crashing. Okay. Now we need to let's adjust. We need to call our adjust feet target, and we want to reference our right foot position, and we also want to grab human body bones, and we want to find the right foot. So dot right foot. Good. And we want to also adjust the feet target reference. We want to find the left foot position, human body bones, and you can guess it, the left foot. Good. Now we want to find and cast, or we can even raycast, find and raycast to the ground to find positions. So this is going to be where we handle it, and this is going to be our our feet position solver, and right foot position, and reference our right foot IK position, and we want to reference our right foot IK rotation. Boom. And this is going to handle the solver for right foot. We also need another position solver, and this is going to be our left foot position. We need the left foot IK position, and we want to reference the left foot IK rotation. This is going to handle the solver for the left foot. Boom, and that is basically all of our fixed update, and that is all done. Also, you can use these really cool things they're basically like XML summaries. So when you hover over here, it's going to fill that out and tell us what we're actually doing inside. So what you can do is you put this in, you put 3 lines, and it's going to give this, and when you hover over it, you can see it says fixed the update. I don't know where it just generates that by default, but we can actually write our own summary about what our function is doing. So we are updating the adjust feet target method, and also finding the position of each foot inside our IK solver position. Well, it's actually inside our solver position. And now when you hover over here, it's going to give you a nice little update about what the actual method is doing, and it's a nice little way to tie everything up. Okay, so our on animator IK, let's fill this guy out. So this one is going to be, we need to if enable the feed IK. So if our feed IK is false, then again we're going to return. Okay, and if anim is also null, so basically if our animator doesn't exist again, we also want to return. Let me just put some spaces in there. That looks nicer. Okay, we want to call our move pelvis height. So this is always going to be running on the animator IK. Okay, now let's focus on sorting out our right foot IK position and rotation. And we also utilize the Pro features in here. Okay, so on our right foot, we want to be grabbing our animator. We want to set the IK position weight. And our IK position weight is the avatar IK goal of our right foot. I'm going to set it to 1. Okay. But if we are using our our use Pro IK feature, so if we're going to be using our professional features, we want to also set the IK rotation weight. So we want to be setting that rotation weight to the avatar IK goal in the right foot. Also, we want to be grabbing the anim get.get float, and our get float should match what we created in here in our variables. So down here in this left foot curve, it needs to match. It needs to match what we've created in our variable name, and that's why it's kind of a professional feature, because it's really easy for people to stuff this up. So just make sure that when you create your animator names in the variables, we'll have a look at it later, but you just want to make sure that these match together nicely. Okay, so let's just come down, and for our right foot, we want to make sure that this is our right foot anim variable name, and one more bracket, and that is done. Okay, so that is the Pro IK feature, and then underneath, outside of that bracket, we also want to move the feet to the IK point, and so this is actually going to be responsible for moving everything. And we want the IK avatar goal. We want to grab that right foot. We want to be setting it to the right foot IK, not the foot position, but the IK position. Make sure that's the IK position. We want to also grab the right foot IK rotation and reference the last right foot position. Okay, now that that's all set up, we can actually copy all of this, because we need to replicate it all for the left foot. Paste it, change this one, and we just want to go through and fix all of the right references to left, and then change this to left, and last right, so last left, because we set up all of our variables with the same uppercase and lowercase. Okay, so let's just double check that all of our left feet options have the left foot variable. I'm pretty sure they do now. Okay, so that looks good. Okay, so that one is finished. Yay. Now let's jump down to let's move to, what should we do now? Okay, let's do the move feet to the IK point. Now, basically, we have been, we've fed through all of the different parts that we need. We've got the position IK, we've got the rotation IK, we've got the last foot position, we've also got the foot IK goal. Now we just need to figure out how we tie it all together and we actually move the feet to the IK position. So what we want to do is we want to create a vector 3, and we want to create a target IK position, and this target IK position is going to be getting the IK position of our foot from our foot IK goal. Done. Oh, didn't close that bracket. Okay, and if our IK our position IK holder is not equal to vector3, 0. So if it isn't equal, then we need to create a target IK position. Oh, we want to actually adjust. We've already created it. We would just want to adjust it, and we want to adjust this to equal the transform, the inverse transform point of this target IK position. And also our our position IK holder should also be inversely transformed, and we want to just inversely transform that one. Okay, let's create a float, and we're going to call this the y_var, so y variable. So basically it's just the y up and down, and we're going to be using mathf. We want to lerp it, and the lerp will take the last foot position and also the position IK holder and .y. We're going to grab that y value and comma, and we also need the feet to IK position speed. So how quickly are we going to be moving it? Okay. Now we want to get our target IK position, and we want to grab that y, and we want to plus or equal that y, and we want to equal this, to the y variable. So that y variable, good. Also, our last foot position y should also equal the y variable. And our target IK position is now equal to the transform. The transform of the transform point of the target IK position. Okay. Also, we need to set the anim set IK rotation, and this IK rotation will be the foot, and the rotation IK holder. That's basically it for that one. Jump out of this if, and then we also just want an anim.set IK position, not rotation, position of the foot and the target IK position. And there we are. So that is our move the feet to the IK point. That is that all set up. Now we want to move our pelvis height. So let me just grab my notes on this one. Okay, so our moving the pelvis height, that one's fairly simple. This one we're just going to start off, let's just expand this out. We just want to start off with if our right foot position IK is equal to vector 3.0, or you can shift and then hold the backspace. You probably see the combination on the screen. Or the left foot IK position is equal to vector 3.0, or that last pelvis position Y is equal to 0. Then we want to change that last pelvis position to equal the anim body position Y. So we're setting that old position, and then we just return. Okay. Then we want to create a float. Let's make this our left offset position. Okay, so our left offset position is left foot IK position dot y minus the transform position dot y. Float right offset position, so we're creating a new float to handle our right. Foot ik position dot y minus the transform position of y. Okay, we need one more, and then just call this the total offset. And if our left offset position is less than the right offset position, then we want to grab that left offset position or the right offset position, and then we're basically just choosing that the lowest position. We want to then create a new vector 3, and this is going to hold our new pelvis position. New pelvis position. There we are. And this is going to be the anim body position plus the vector 3 up times the total offset. And then our new pelvis position dot y is equal to a math lerp, and we're lerping that last pelvis position to the new pelvis position. So we're grabbing that last one, we want to grab the y position of that, and we want to times this by the up and down speed of the pelvis. Okay, now we want to grab our animated body position, so where the actual animated body is, and we want to equal that to our new pelvis position. And our last pelvis position is now equal to the anim dot, not the Android input, but the anim body position dot y. So we're basically setting that old position to this position, and we're setting new position to that position, and that is all nice and dandy. Okay, so that is the moving of the pelvis height. So that one is sorted. So we have two more methods left to go. We have the find feet position solver. So let's sort this one. Oh, sorry, the feet position solver. So let's sort that out. So basically, this is going to be the raycast handling section. You can also do the summary again, and see also when you do these, it's really cool because it feeds in all of your parameter names, and then it gives you this. So when you hover over these, it says from the sky position, feet positions, feet IK rotations, except the automatically generated name doesn't really fit for this one. Feet's the position solver. So we want to create this and say we are locating the feet position via a raycast solver, and then via raycast and then solving, and then that's going to feed through to here. Okay, so our raycast handling section, we need to create a raycast hit, and this is going to be our feet out hit. So this is going to hold our hit. If show solver debug, so if that's enabled, I don't think we even need to worry about the brackets, but if that, then we're going to draw a line, and we're going to draw a line from the sky position just down, so plus vector 3 down. So we're just going to grab that, so we're getting this position from the start, then we're going to grab that position and then plus that down, and we're going to times that down by the actual raycast distance plus the height from the ground raycast, and that's going to adjust that. And also we want to create a nice little color, so let's make this yellow, capital C. Good. And close that one out. There we go. So that's just that, in case you want to see it. Okay, and that is that for that one. Let's just expand this down a bit. Perfect. So now that we have that one, let's do the actual raycast. So if physics.raycast, so if the physics.raycast from the sky position, and we take that vector 3 down, we want to put the out to the feed out, and we want to take that distance, and it's really nice because the prefill, or the thing that they call it IntelliSense, shows you all the different options. So right now, let's finish this one. So this one is the out, the out raycast distance down plus the height from the ground, and then we also want to take this against our environment layer, so it's only hitting the environment layer. Excellent. Oh, and then if this is all fine, then we want to then do stuff inside it. So we want to grab the feet IK positions equal to the from sky position. Feet IK positions dot y should equal the feet out dot point dot y plus the pelvis height offset. Pelvis offset. Okay, and now the feet IK rotations is equal to quaternion from to rotation vector 3 dot up feet out hit dot normal, and then we times the transform dot rotation, and then we return back to the start. So we'll jump back out of this raycast. We have everything we need, and then we just want to say that the feet IK positions are now equal to vector 3 dot 0. Or this technically means that it didn't work. Sad face. So basically that's just going to grab all of our positions, finding our feet IK positions from the sky position. Okay, and now our final one, where we're just adjusting the actual feet target. So this one, what we're going to do, our feet positions is equal to the anim.getBone transform. We're grabbing the foot and then dot position. Our feet positions dot y is equal to the transform dot position dot y plus the height from the ground raycast. Okay. And that is that one. Okay, so now you should be able to close this down, so you'll be able to trim these down. But for now, let's just come and do a little bit more tidying up. That one's actually not bad. This one shouldn't be bad either. Moves the height of the pelvis and adjust the feet target. Okay, that's actually did a pretty good job. Okay, let's just trim these down. Feet grounding, player movement, and our variables. Okay, now let's jump back to Unity and see if it's going to give us any errors. No. Perfect. So pretty much right from here we should be able to press play and we should get our IK system. Okay, there you go. So now we have a really nice IK system all built. Let's just come over to this little ledge that we looked at the start. So there you go. Our pelvis position automatically updates and the feet place properly. Let's just jump down to here and have a look at this one. So there we go. Now you can see our feet positioned correctly in all the different situations. Let's try and get that to sit there. There you go. So that's the leg sitting correctly. And we can even come to here. There you go. So there you go. That's the IK system all sorted. So that's basically how you build that pretty much from scratch. And as you can see, if we turn up this the speed, the up and down, we're doing that, and we're doing that. That's gonna keep the player in check. But if you have this too low, you'll notice that he's not going to adjust quickly enough when you go up, and he's going to kind of sink into the floor. So you'll find the sweet spot where he's going to adjust quickly enough for you. Okay, so you can see the raycasts happening of our feet where it's finding the positions, and you can also draw gizmos that will actually demonstrate this a bit more as well. So if you go void on draw gizmos, and then you can actually fill this out to give you what you want. So you can create different transforms and more debugging inside here. But probably for now, I think what we have is enough to actually handle what we need. And I think that should be okay. But if you do need to expand it more, you can use that on draw gizmos and create lines and stuff you can calculate with distances between your legs and your arms, and that's gonna be a good way to debug it. Now to demonstrate the foot curves, what we need to do, let's click play. Now I already have this set up, I believe. Do I? An animator? Yes, I have the 2 left foot curves. So if I parent this to the side and we click play, you'll notice that the curves go up and down, and these are actually set from our animator, from our animations, and then you have to manually go and set these. So when the left foot curve is 1, that means it's grounded, and when the right foot curve is grounded, that means it's also 1. But when it's going in between it, it's going up and down, up and down, up and down. It's basically saying that left foot is up, left foot is down, left foot is up, left foot is down, right foot is up, etc., etc., and that's going on. So if we enable this pro feature now, it's actually going to take into account rotations. So if we come into here, now you can see we have these really nice rotations happening. If I click here, where are we? And we come into here, and if I uncheck it, no rotations. So that's our Pro IK feature, and that's how that all functions. Now let me show you what the actual animations look like. So if we jump into here, and we go down to idle, just make this smaller, because we know idle, both feet are on the ground. And so both feet are set at 1. So if we go to like walk forward, when our feet, so currently our right foot is on the ground, our left foot is up, our left foot is down, so that's 1, and right foot is up. So you can come through, and let's just, I can do walk slow. This one doesn't have it yet, so I can show you how you can quickly set it up. So come down to here, just kind of focus on his feet, click new curve, create a left foot curve, and you can create a right foot curve. Foot curve. Okay, and look down here. Okay, now technically our right foot is 1, our left foot is 0. Let's go forward, and now our right foot is 0, our left foot is 1. So you can create keyframe, not 14, it's 1. Now our right foot is now 1, our left foot is 0, and right foot at the end here is 1. Now we have a nice little loop happening, and that's how you set up the curves. And basically when these curves they actually get driven straight through to the grounding method. Where did we have it? I think actually, sorry, it was in the feed grounding. Yeah. So when we have it enabled, we're actually grabbing that rotation weight, and we're setting this to the actual float, depending on how strong that is. So that's a nice little feature just to throw in there. Perfect. So there you go. So that's basically start to finish on how we can create an IK solver. We have our IK system. Nice and simple. Not sure how long this recording is probably gone for. It's probably close to 40 minutes or something. But it should give everyone a pretty decent understanding of how it all works. Runs really smooth. What's our frame rate at? 340. That's not bad. Yeah. So thanks everyone for watching, and please let me know if you have any other questions. I'm more than happy to answer them. And you all have a good one.